What's up, YouTube? Today I'm going to be mocking. Get that? I mean, who came up with this term, first of all? For those of you who don't know what mocking means, it means making fun of someone in an insulting manner. Right? So you're saying something that seems to be kind of joking or jovial, but you're really insulting them. Yeah, so that's it. I don't like mocking because it is insulting, and that's all I got to say about it. So I will see you next time. Actually, there are just a lot of things wrong with mocking. Now, today we're going to be talking about mocking and, of course, testing, since unless you're doing something else when you mock. And so they go hand in hand. And I will be talking about something Ken Beck said when he talked about TDD. Ken Beck was the person that sort of introduced TDD to the software community many years ago, and some things that Martin Fowler has said in the recent past, about mocking. And then I'll give you, of course, my own opinion. Now, I still have, nothing has changed, a lot of problems with mocking. So one is the practice of testing in isolation, right? To me, that doesn't make sense. Now, maybe because of my background, I don't think in those terms. If you remember from the previous video on dependency injection, I talked about how the graphics card is a sort of a component by itself, and the graphics card has got thousands of components on it. But you don't want to test all of the components on the graphics card. You plug it in the motherboard, the system is comprised of a graphics card, but you're not going to be testing the graphics card as a composite, as I call it, will exist. There will be tests for that, but not all the parts and pieces on the graphics card and all the parts and pieces on the RAM chip and so on and so forth. In the electronics field, we have a lot of testing. I mean, when was the last time you bought a TV that didn't work for like at least 5 years? I mean, they go on for decades, but you're not expected to use a TV beyond 5 years because there's a new technology by then. And in the software, in the electronics field, we call it test jigs or test rigs. And you would have, so if I was manufacturing a graphics card, I would be testing it in a test jig, where I would literally insert the graphics card in that jig, and I would simulate the interface of what the PC provides it and ensure it does everything correctly. And I'll probably have ways to do that as a complete graphics card. Right now, they have debug points on the PCBs typically, but that's when it's already assembled and somebody brings their PC to you and you're trying to figure out what's happening. So as a technician, you would kind of need those points. But anyway, I'll come back to this idea, but essentially that's one problem I have with mocking, is that for whatever reason, people think that testing classes in isolation is a good thing. All right? The problem with that concept that I have is, if class A depends on class B and C, the mockus is a term that Martin Fowler uses for people who do mocking. So I'm not sure don't mean to insult anyone, but in case somebody's getting insulted because I'm saying mockus, it's because that's what Martin Fowler calls them. The mockus will want to test class A without B and C. So A has a dependency on B and C, and so they want to test A without B and C. So they want to test A in isolation, and that's what we call testing in isolation. It seems, the concept seems okay, in first blush. Yeah, I mean, why would you do that? But when you look at it closely, you realize that there are issues with that idea. Forget the practice, which is, do I want to know that A has a dependency on B and C? Why do I want to know? Why do I care? Now, of course, they have reasons that say, oh, but when something goes wrong, you can't tell whether B is the problem or C is the problem or A is the problem. Really? You can't tell? I mean, is your software written so badly that you can't tell? I can tell. I mean, my exception messages should be very clear, and I would know that. And then you are debugging, right? You're testing not in production, right? You don't send the testing code out of production and start testing unit tests in production and hoping for the best and being able to nail down the problem right away. I mean, that is insane. If somebody says you have problems finding out, let's say, like I'm testing something like the size of a graphics card, which is just a component of the system, right? And that graphics card's got thousands of parts on it. Okay. Yeah. I mean, I'm sorry. I mean, I've built very, very complex systems in my lifetime and a programming lifetime, software lifetime. My lifetime is comprised of two parts, the electronics side and then the programming side. And I've never had that problem. When you are working with the debugger, I mean, today's debuggers are way, way better than the debuggers, that we had before, at least when I started programming. And I don't think that should be a reason. Now, the thing with humans, myself included, somebody at work was talking to me about my dependency injection video and not making fun of, but he was cracking up on this some of the things I said to him as humans, and I sort of include myself thing. And I want to make sure people understand that when I'm talking with humans, I'm not distancing myself away from it, right? It's just because, I mean, I'm prey to the same thing. I'm guilty of the same things. There's a joke, and it goes like this. I'm going to try to explain our human tendencies, or this guy walking down the street in the night, and up ahead he sees this person under a street light, so you can see him because he's under the street light, and this person is kind of on his hands and knees, seems to be looking for something. So finally he walks up to him and says, like, have you lost something? And the guy looks up at him and says, yeah, I lost my keys. So this guy now bends down on his hands and knees and helping this person to search for these keys under the street light. And he finally gives up. He says, are you sure you lost your keys here? And the guy says, no, I didn't lose the keys. Yeah, I lost them over there. So he says, so why are you looking for the keys here? He says, the light is here. This is what we're guilty of, humans. We do what we can, not what we should. We should be searching for the keys in the darkness. But because it's easier for us to search for something under the light, we look for it under the light, right? We do what we can, and then it gets even worse, okay? We are a class act. We are specialists in kidding ourselves, right? So now that we want to look under the light, so in this case, now that so in our testing metaphor, integration testing is hard. Well, it depends, right? I mean, if I'm a marathon runner and I'm used to running a marathon, and then somebody says, now you got to run 5 miles, you think I'm going to call it hard? Of course not. But if you're not even used to running, and I say, let's go running for a mile, even a mile is going to be painful, right? So hard is, I guess, relative. Okay, nonetheless, I'm contrasting integration testing, what I call end-to-end integration testing, because this is another problem we have in the software field is terminology. We just overload terminologies galore. Like the same word will be used to mean 15 different things. And as a result, we can't have a conversation, right? Because, well, you probably think you're understanding me, but you're not. Because each of the words I'm using makes sense to you, but the meaning that you're getting from the words that I'm saying may not have the same meaning because we have these overloaded terms, right? So I sort of overemphasize end-to-end integration testing. I'm testing the entire system, and I'll get back to that. But to move on with this metaphor of we do what we can, and not what we should. And that is, so you like mocking. No, I'm not saying you like mocking. I'm saying, what if? I mean, as a conversational piece, if you like, just as an example, if you like mocking. Right? I'm not accusing you of liking mocking. So you like mocking, and you have to do certain things, and then people start to complain about it. So you start to build an entire story around it, right? You start to come up with all kinds of reasons for why mocking is good, because that's what you can do. You can't do the other thing, which is integration testing. So you start to find all kinds of reasons and faults and problems with that testing, because I mean, it's dark, right? You can't look for it in the light, in the darkness. So you say, well, the light is here, so I'm looking for it over here. That's what you're doing. We are a class act. We come up with all kinds of reasonings and justifications and rationalizations for what we are doing, because that's what we want to do, that's what we can do. What we should be doing is completely different from what we can do. So that's my take. Not just about mocking, as I said, we have this fault, and I'm guilty of that too, but I'm also very conscious of it. I'm constantly trying to kind of, like as an introspection, it's like playing, devil's advocate. Am I doing this because it's convenient, because it's easy, because I can do it, because I know how to do it? Or is it do I actually honestly believe this is what I should be doing? Right? I'm constantly in that battle when I'm making choices, not just in software. I think you haven't heard about my diet. If you heard about what I eat or don't eat, most of you probably run away. I actually have a channel on YouTube called Living with Intent. Probably search for it and find it if you're interested, but I don't spend a whole lot of time on that channel. But you'll get a sense of what I do in my diet. Anyway, I don't want to spend too much time here on that. So they're saying, the mockers are saying, that classes shouldn't lie. Classes should expose their dependencies in the constructor. Like, yeah, you first do what you're doing, and then you define it as a problem for when it's not being done, right? That is like, I'm looking under this light because I'm looking here because there's a light here. Now that you're looking here because there's a light here, you're justifying why you're here, looking for the keys under the light, not like where you should be. And that's, of course, a problem. And so, if you understood this is idea, and I'm not going to keep reiterating this, but now I'm going to go back to the issue, the sort of the technical aspect of it from a design standpoint. When I design a class A that might have dependencies B, C, D, I don't really care how many, I don't want to know. I mean, I'm being serious. I'm not kidding at all. I don't care. I don't want to know. I mean, I really don't want to know. I would never want to know. So therefore, if I'm testing class A, I'm testing class A. I'm not interested in mocking anything. That class, as I mentioned before, this is all sounding very familiar now to me, has to work by itself. It's like if you have an issue, right? Let's say, go to start your car. It doesn't start. That's it. You're done. You know what I mean? No, I would go and open the bonnet and look under the hood and fix it. I would, but the general public just gets fed up. I mean, it very well just start when I turn the key, or maybe these days you push a button. Right? If you push a button and nothing happens, that's it. You're done. For me, that's the class. I knew it up. It just bloody well worked. If it doesn't work, I don't need to use it. Now it can complain to me. It can throw exceptions and tell me it's missing something. Yes, that's a totally different problem. That is a one-time thing, when you're setting it up. After that, there are no complaints. So while the mockers are trying to justify why they test in isolation, I'm saying I don't care to test in isolation. So now to the equivalent of the graphics card metaphor and the motherboard kind of thing. When I do testing, it's very simple. I start with the end-to-end integration tests. These are functional tests. These are acceptance tests. These are tests to test every business scenario. I am building a system that has a certain set of requirements, and each requirement has n number of scenarios. That's what I'm testing. So for me, if my system is comprised of 1,000 little components here and there, I'm testing the whole thing. If it's dependent on services and a database, I'm testing everything. Now that's where I start off. Now there may be some scenarios, very rare, because I'm going to keep pushing to test the entire system end to end. But yes, maybe sometimes if I'm talking to an external service, there are scenarios where I cannot get that service to throw an exception when I need it, when I'm doing my testing, right? So I can't reproduce the problem, the scenario on the service. I can do it on my end, but I can't actually have the service throw an exception. So in those cases, I will use, and we'll talk about this later on, what I call a test double, which is a stand-in, a double as in, stunt double, test double, instead of something in my system. Now in .NET, it turns out that something I'm replacing is not even my class. It's part of the .NET framework, which means I am not testing anything that I have written. So even when I do use a stand-in for those exceptional scenarios, what I call edge case tests, I'm testing the code I wrote 100%. Database, yes, I will use my database, not somebody else's database. My database, my store procs, everything, I'm going to have to test it. Listen, I can't go to production under any circumstances unless I have complete faith in the system I'm building. Can you? Exactly. So if we should not, some of you may be able to, but if we should not go to production without testing every part and every aspect, every scenario, every feature and every scenario, without testing every scenario, then why waste time testing the parts and the pieces that make up the system? It's asinine. It doesn't even make sense. Okay, now, the Marcus, or even the unit testers. Now, the unit testers, what the heck is a unit test? I don't know. Your guess is as good as mine. So I'll define unit test for this conversation. In Ken Beck's opinion, a unit test is a unit of work. It's a functional unit of work. It's not a class. It's not a method. It's not a property. It's an entire functional unit of work. It's a functional feature. It's a unit of work, and you're testing that. Roy Oshrov says the same thing. He's got a different way to say it, but basically he's saying it could comprise n number of classes and methods and whatever else. It doesn't matter. A unit test is a single functional requirement. But apparently we didn't hear that. We forgot what Ken Beck had to say, and Roy Oshrov more recently has said the same thing. For most people, then, a unit is a class. But wait, it gets worse. A unit could be a method. A unit could be, I don't know what the heck it is. It's just a unit. So for this discussion, we'll say, for those who do unit testing at the class level, right? So it's not method level, please. And certainly don't have to use reflection to do it. There's a lot of people who will test internal methods and private methods, and oh my God, these people are just, I can't understand it. Anyways, if you're doing class level testing, I actually call them class tests. I use the category attribute on test methods, and I give them different categories, and I may have class tests. I'm not saying I don't ever do class tests, and I'll tell you why I'll do those at a later point. But because they're doing unit testing, which is unit level, class level testing, they have to test in isolation, because for them a unit test is unit test, and you can't test two units together. So you have to test in isolation. All right. The other problem I have is, as I said before, I don't want to know. But what's the problem with that? Okay, I might have my own, preference, and I'm just an idiot. So guess what? I gotta have these idiotic preferences. Cool. I'm good with that. From a design standpoint, If on the testing side, you know, and you have to know since you're mocking, aren't you? That class A has a dependency on B and C. If you know that, on the production side, you also have to know that on the testing side. So you have to mock B. You have to, by the way, I should have mentioned this before. I'm not going to explain mocking in the sense of helping you learn how to do the mocking. Please don't learn it, right? That's my take on it. Don't bother. But to understand this conversation, you might have to understand mocking, since I'm not going to try and explain every part of mocking that I'm going to talk about here. So I'm going to mock B, I'm going to mock C in order to test A. And so I'm going to inject. I mean, how else would I send the mocks in, right? You see what's going on? In my honest opinion, it's the mocking that drives the dependency injection. If people would just, goddamn it, own up to that. It's because they want to do mocking that they're doing dependency injection. That's all it is. There's no other reason to explain that you dependency inject every single class in your system. Just can't explain it. You cannot convince me that there's a valid reason for doing that. I mean, I get, dependency inversion and all that, but what drives, in my opinion, what drives dependency injection for the most part is mocking. The way dependency injection is being done by most people, which is inject every single thing, is because they're trying to mock. That's what drives dependency injection. If you have to mock B and C in your tests, you have to be aware in your tests that A has the dependency of B and C. And, it gets better. It gets so much worse. All right. But in order to use the mocks, the B and the C mocks, you have to know which method on B and C that A is calling. Oh my gosh, you're just tanking at this point. The coupling, the knowledge that your tests have about your implementation is way, way too much. What's the problem with that? Yeah, try and refactor your code on the production side and see what happens to your tests. Now, the way Ken Beck talks about TDD in his book, he's got 2 books. Yeah, it's like this. Now, maybe I'll back this conversation with some sort of a diagram thing, and after I've shot this video, but I don't know if I can sync it all up in time. He says, when you're doing test-driven development, it's not design. It is development. Please don't make that stupid mistake of saying it's test-driven design. It's not. Bob Martin might want to say it's test-driven design. Ken Beck doesn't say it's design. He's very clear in what he's saying. He's saying you are not designing. You are at this point in time testing. So he says, write your tests in this features, right? So every feature has a scenario. So let's say this one feature has a scenario, n number of scenarios. You then write the code, the production code, as simply as possible. Remember, as simply as possible. What does he mean by simple? Now, you might have your own understanding. Okay, tell me what it is. No, it's not that. How do I know what you thought is incorrect? Because nobody gets it. Well, again, it's simple, right? Simple. How hard can it be? Another old-worded term. As simply as possible in Ken Beck's mind is, and I'm sort of translating, what he means. He's basically saying, don't try and design the production system. That's not your job to do at this point. You are testing. Implement the entire code, let's say in a method. Every single thing, real code. And that's another problem. People think, just write some stupid code to make the test pass. He's never said that. As simply as possible, he means full out production code, production quality code, but without trying to decompose that feature into classes. You are not designing, you are testing. So keep the testing hat on, focus on the testing, and implement the code that's going to make those tests pass as simply as possible. Meaning, at least for the conversation purposes, in one method of a class. Right? So you just say, here's a class, whatever you want to call it, and it's got this one method on it that implements that feature, and you implement the whole thing in that one method. Because you're not trying to design your system, you're not trying to decompose that implementation into different classes. One class, one method, one feature, one method. Now you have n number of scenarios for the features, so there's so many tests that you have, test methods that you have. Red, green, refactor, that's another thing people have missed out, they are misunderstood. Red is not working, green now that's working. Refactor, what are you refactoring? No, you're not refactoring the implementation, you're refactoring the tests. As far as Ken Beck is concerned, he meant now refactor the tests. You want to make sure your tests are clean and always maintain to be clean production quality code. These are not throwaways. These are going to be holding you for a lifetime. So you protect the test code, not letting it rot by refactoring the tests. As you start to write tests, you just keep refactoring. Red, green, refactor. Red, green, refactor the test. Red, green. He should probably said that. I don't know why he didn't say. Why can't people speak clearly? Or write clearly. I just don't get it. The reason I'm talking about this is that tests have a purpose and a meaning in the system. The biggest benefit of testing, probably the only reason a customer or your company, if you're employed or a consultant, is willing to give you the time, therefore pay you to write all these tests, is for regression. Regression really essentially says, as you keep adding on features to the system, you should not break what was working before. Right? That's regression. So regression testing. As you add on more features to the system, by having this suite of tests that you have, that become the regression tests, you can ensure that that system is working the way it was before. Even though you added new things, what was working before is not broken. So the biggest benefit for testing is regression testing, which means you can't modify the tests after they've been written and they're successful and that part of the system has gone to production. Once that part of the system has gone to the production, all those tests should be literally carved in stone. Okay, so just think about this one method with so many scenarios, therefore so many test methods. What Ken Beck says, it's going back to the testing part by the way, is once you've written your tests and you've done this simple implementation and everything's working, so okay, now you got a suite of tests. Now, later, at some point, you wear your designer hat. Make sure you go on a vacation before you come back. Then wear your designer hat and then go start designing the system. And he says that shouldn't break your tests. All right. So you tell me, how in the heck can you mock, then refactor? So what I don't understand is how the mockers can pull this off, right? Because if you're refactoring, right? Let me just explain refactoring, just so everyone's on the same page here. What refactoring means is business requirements have not changed. You're not modifying the system because requirements have changed. You are, as a good software engineer should, constantly. You're not allowing your system to rot. So you're refactoring. As you're building on new features, you want to keep that production code cleaner, maintainable. You refactor. Maybe some classes disappear, new classes come in. Maybe two classes get collapsed into one class. What does the refactoring implies? Tests should not break. That's what Ken Beck says. Adding new classes is not a signal to add more tests. These guys just missed the book. I don't understand what they do. How do they explain that? I don't understand how they can pull this off. The problem with mocking and knowing the dependencies, even on the testing side, is your tests are totally coupled to implementation. You know which classes depend on which classes. Heck, you know what, a lot more than that. You know which method. So going back to this class A, B, C thing. You know which method class A is calling on B. and you know which method on B that class A is calling. You know which method on class C A is calling. But wait, it gets worse. You know what the parameters to these methods are, their types, how many they are. You also know what the heck this thing is returning. What is the method returning to A? And the mockers love to know that. I haven't a clue why they love to know this. Like, what is it? I mean, are you some sort of control freaks that you want to know everything about everything and who's doing what to whom? I mean, seriously? I don't care. I don't want to know about anything. I'm simply trying to test my system and get it to production, right? So my problem is it's too much information is coupling the whole thing together. I mean, people have come to me at work, in over the years. I mean, in different organizations. Every time, so the recent one was, hey Shiv, so this is another architect. Hey, like on my team, the devs fix the bug in 2 days, then it takes them 2 weeks to fix the tests. Well, how do you guys sort that out? I literally just said, we don't do your kind of testing. He said, what do you mean? And then I went through the whole spiel of that. They actually changed over to what I do. And that's a long story though. I mean, they didn't walk back to his desk and change everything, but there's like a plan to migrate over. But they did that because what happens with mocking is, and I call it, this is what I say, a sneeze on the production side is an earthquake on the testing side. Right? A sneeze on the production side is an earthquake on the testing side. That's what mocking sort of seems to me like. The problem with that, okay, let's say the time is not a problem, Shiv. I don't mind spending the time, that earthquake, I'll fix the earthquake, I'll repair all the roads and the bridges and the buildings and, I'll get all back. Okay, cool. But what happened to your regression then? I mean, how do you know, now that you have to rewrite all the tests, right? You've touched your test methods in some form or fashion. How can you trust those implementations now? I mean, what does the regression mean? Regression means you can continue to refactor your implementation, your design of the system. Don't touch the tests. Just keep running the tests. And if the tests are consistently passing, and provided, of course, you've caught all the scenarios and stuff like that. If all the tests are running and passing, and you've completely redesigned this entire system on this end, send it to production. You should have the faith. You should be able to give the businesses, your customers, your bosses, the guarantees that yes, this system, it may have some other bugs we don't know about, but this is working exactly like the previous version did. You can't give that guarantee to the business. I don't want to make this a whole long thing, but in my current job a few years ago, I had a scenario where I had to take something to production like overnight, like short notice. And I was asked, can we take what we have in our repositories to production? I said, yeah. Do you have that confidence when you mock? Yeah, I'm talking to you. I don't mind having an honest debate with people who mock. I just need to be convinced. I am too logical, scientific. I need evidence. I need to have an A and a B study, what we would call in the food industry, double-blind control study. I don't just believe stuff, for the heck of believing it. I need to know for myself. If somebody can convince me by showing me what mocking and the benefits are, I might make another video then tomorrow. What I'm going to call this? Mocking? Yes, please. No, thank you. Not at this point, okay? And that's the other thing with me is I will change my choices, my preferences in a second. I just need to be convinced. I'm not married to what I do today. The moment I find something better than what I'm doing today, I'll switch to that. I'll keep doing that till, I die. So the issue with mocking, one of the issues is knowing the dependencies that cause your test code to be tightly coupled to your implementation. Thereby, if you were to refactor your implementation, you have to rewrite or modify the tests. which makes your regression testing invalidated. That's the point of testing. That's why the business is paying you big bucks for the extra time. All right, that's the thing. Now, when you're mocking, or when they're mocking, since I know you guys aren't, if you are, when you're mocking, they want this intimate knowledge about every little thing that's going on, right? Now here's another example of what they know. So not only do they know the methods that A is calling on B and C by name, they know the arguments and the types of the arguments, they know the return types. But wait, as I said, it gets worse. There are some mockers who even deeper than this. So let's say this method on B that A is calling, if you can imagine this. So A is calling B internally to A is calling B some method. And this method takes an argument of some DTO type that is, let's say, 5 properties. And wait for it. When you're testing, when they're testing, they set the DTO of the same type with those exact values, and when they set up the mock, they're saying, oh, and by the way, this argument that is going into this method that A is calling should have exactly these values. Now remember, they're not sending this DTO to A to send to B. They're sending some other information to A. A internally is doing whatever magic A is supposed to do before it calls B. It creates an instance of this DTO, it sets those values, how it did it. It's not known by the injection by the things that you're injecting into the constructor, right? It's not like you know that. So in other words, we can visualize the method. A does a few things. So there's so much of all these lines of code that does something there. Should I be doing it backwards? This way? Does 10 things, and then it's calling B's method, right? You sent A in the constructor some information. How do you know? Okay, and even if you send A some method arguments, what I'm trying to get at is the arguments is not one of the DTOs that is being sent to B. It might use the information you send it in the constructor, inclusive of the arguments you might have sent to the method you're calling in your test. That method has then done a bunch of things before it calls B's method, and just before calling B, this DTO has been hydrated by A through all kinds of magic internal to A that you should certainly not know in your tests. But yet, the mockers, the pure mockers, these are people who like the strict mode and the very, very strict mode, will actually, in this time when they're setting up the test, will say, oh, and by the way, when A calls B, this method, that DTO, it should look exactly like this. Oh my gosh. Oh gosh. Anyway, it just scares me. The coupling is so tight. I mean, it's literally, so here's what I do, all right? When I write tests, I write end-to-end integration tests. I will take care of every single scenario that I know of that I've been told has to be taken care of, and I've also imagined some that are applicable scenarios that I'll write tests for, right? You know what I'm doing when I'm writing those tests, those functional tests? I'm ensuring by writing all the different tests I can that I lock the system down in place, meaning if the system starts to drift even the little slightest bit, some tests have to break. That is what I'm trying to do at the functional testing, end-to-end integration testing level. If anything changes from the norm, tests have to break. Otherwise, those tests, I don't have enough tests, right? I'm truly trying to lock the system in place, like with super glue, right? The slightest budge, and I need tests to break, at least one test to break. That is what I'm trying to do when I do end-to-end integration testing. Yes, it's a lot of work. I mean, so who cares, right? I mean, is that the reason you should not do it? On the mocking side, they're doing the same thing, but they're locking the implementation down. So much so that you can't change the implementation one bit. Ooh, oh my God, that's just it. I mean, I got goosebumps just thinking about it. I'm like, it is scary what happens with mocking. Now, yes, I understand that not all the mockers do this and not all the dependency injection people do that. I'm talking about the general the general practice that I've seen. There are a lot of people who turn on like strict mocking and then even go even further, right? And some mockers will say, well, I just want to do mocking a little bit. My problem is, for the most part, most of them are not even testing what they should be testing, right? They're doing what they can and they're not doing what they should. I just don't get that. Why spend all this energy and effort on something that doesn't even make sense? I have fewer tests, even though I'm testing end-to-end integration tests, testing every feature, every scenario of every feature, 10 ways and back. I don't mean I'm writing extra code. I just mean I'm covering every single aspect. Like, I want to lock that system down so it can't budge. And I have fewer tests, orders of magnitude fewer tests, to ensure that my system is fully functional as the requirements that I've been given. I mean, of course, I can understand I got wrong requirements. I didn't get all the requirements. I don't consider those. I can only do what I know or what I've been told. So then the mockers would have in their system, the tests take the same time. Anyone that tells you integration tests are way too slow, I don't know. I mean, what the heck are you writing in your code? Yes, of course, service calls are going to be slower and database calls are going to take time. It's a network hop. Is that to say databases are slower? No, they're not. Is that to say the services are slower? No, they're not. I mean, let's assume that the people who wrote the service are as good as programmers as we are, right? So then, like, how come magically the service itself is slow? It's not. The network call will take some time. It's typically 100 milliseconds per hop, right? That's like telling a manufacturer of a vehicle, like, hey, I need a car right now. Don't bother with all your testing. Just send it over, right? Yeah. Oh, there's a metaphor a colleague of mine at work told me yesterday. In fact, I was talking to him about me. I'm planning to make this video, and so I was telling him that the mockers tests the parts and the pieces, and they'll do a little bit of integration testing. It's just like for namesake, just to say we've done integration testing. They're not trying to test like the whole system. They do some end-to-end testing and say, okay, now it's all working, cool. So go to production, right? So the metaphor he used was, that's like walking into a car dealership. And the reason I brought up car dealership is why I was giving him this metaphor. Like, if you were to go buy a car to a car dealer, and the dealer is praising the fact that the manufacturer of this car has tested every part and piece, and he's not mentioning anything about the car itself, right? So you ask him, like, has the manufacturer tested the car? I mean, like, okay, the parts and pieces is one thing, but have they actually bothered to test the car once it was all assembled? And of course, like, that's what's more important. And he brought up the metaphor saying, it's like if you went to buy the car and you just kind of drive it around the block and say, yep, I'm ready to buy it. Now, maybe you are willing to, drive it around the block and buy it because you've read 10,000 reviews of other people that you trust, and on and on and on. But if you had no idea about that car and you were the very first person to go in to buy the car, would you just take it around the block? Would you expect the manufacturer to have tested that car? When you buy a TV, you expect them to have put that TV through its paces, not the parts and the pieces, but the entire TV through its paces, through heat, humidity, vibrations, months and months and months and years and years and years of the TV remaining on. You don't think they've done that? Do you think they just put all the parts and pieces that were tested and say, yep, the TV comes on, I see a good picture, cool, ship it. Let's get real. If you want to spend all your time doing the mocking, and there's a video on YouTube I saw many years ago. It was done by people from Google, and the title of the video is interesting. It says, "Stop mocking and start testing." I think that is the most apt statement I can make to anyone that mocks, that's a mockist. Right? I see mockist is better than mocks, because if I tell people I mock, the question would be, whom? Who are you mocking? Stop mocking and start testing. And I will see you next time.